Hello and welcome to my channel. I am Mensah Augustine. Please, if you are new here, kindly subscribe to my channel. And if you have been watching my videos and you've not yet subscribed, please kindly subscribe to us to the mathematics community. In this lesson, we are going to look at our principle of mathematical induction. So we are going to prove using the principle of mathematical induction. So let's look at the question. We have to use the principle of mathematical induction and prove that 1 times 3 plus 3 times 5 plus 5 times 7 plus up to into bracket 2n minus 1 times 2 times n plus 1 is equal to n times into bracket 4 times n squared plus 6 times n minus 1 all divided by 3. Please kindly subscribe, like the videos, share and leave your comments. If you have any question that you would like me to help, just send it to my WhatsApp number plus 2332453 0793. Now, for the principle of mathematical induction, first we let the given statement be Pn. So this is the given statement. We let it be equal to Pn, and then prove that the base case is true. That is, the base is taking n equal to 1. So that's the first step. So if we take n equal to 1, we put 1 here. That is what I've done here. So 1 times into bracket 4 times 1 squared plus 6 times 1 minus 1. This gives 1 times into bracket 4 plus 6 minus 1. That gives 1 times 9 divided by 3. 3 will divide 9, 3. So we have 1 times 3, which is 2. That is what we have here. Then we move to the inductive hypothesis. That is, assuming that k is true, then we sum from 1 times 3 up to k. So we have 1 times 3 plus 3 times 5 plus 5 times 7 plus dot dot dot, and here we replace this n by k. Replace n by k, so we have 2 times k minus 1 times 2 times k plus 1 equal to k times bracket 4 times k squared plus 6 times k minus 1 all divided by 3. Now, the next step, after we've done the inductive hypothesis, then we prove that p into k plus 1 is also true, assuming that pk is true. So we sum from 1 times 3 plus 3 times 5 plus 5 times 7 up to 2 times k minus 1 times 2 times k plus 1 plus, so this is k plus 1. So here, whenever you see n, you put there k plus 1. So you have 2 times k plus 1 minus 1 by replacing n by k plus 1 times 2 times k plus 1 plus 1. Now, let's look at something. You see that this part is exactly what we have here. That is k, right? And if we sum from 1 times 3 up to k, we are going to get what we have here. K times into 4k squared plus 6k minus 1 all divided by 3. So, in place of this, we have pk plus 1 is equal to k times 4k squared plus 6k minus 1 all divided by 3 plus what we have here. So let me expand that one. So that one will give me 2 times k, 2k, 2 times 1 is 2 minus 1. 2 times k is 2k, 2 times 1 is 2 plus 1. This gives us 2k plus 1 times 2k plus 3. So let's expand. 2k times 2k is 4k squared. 2k times 3 is 6k. 1 times 2k is 2k. 1 times 3 is 3. So this gives us 4k squared plus 8k plus 3. So we put that one here. 4k squared plus 8k plus 3. Now we have a pk plus 1 equals, let's simplify this one. This is over 1, so the LCM is 3. 3 divided 3, 1. 1 times k is k, so we expand this to get 4k plus 6k squared minus k. 1 will divide this 3. 3 times 4k squared is plus 12k squared. 3 times 8k is 24k. 3 times 3 is 9. Wow. So we are going to have pk plus 1 to be 4k plus 18k squared plus 23k plus 9, all divided by 3 as pk plus 1. Now here, you have to take a very good look at what I'm going to do. What I'm going to do here is very simple and you should just follow me. Now, what are we going to do? What we are going to do here is very simple. This is what we have. But at the end of the day, what are we expecting to get? We are expecting to get, look at what we have here. In our final answer, we should get n. But this n in our final answer should become k plus 1. Because we want k plus 1 to be here, that is n. Because here we are saying that n is equal to k plus 1. So we want to prove that here you have k plus 1 here. Times 4 times k plus 1 squared plus 6 times k plus 1 minus 1. All divided by 3. This is what we want to prove. Because if we put in k, you see that you have k in place of n, k in place of n, k in place of n. So once you put in k plus 1, it means that you should have k plus 1 in place of this n, k plus 1, k plus 1. That is why I'll be able to write this. So always, you can write the final answer. But how do we prove this final answer? Okay, we can prove it in 2 ways. Here we can use the long division method, because here you have a cubic function here. So you can find the factors of this, so that if we put inside this, we get 0 and then go and divide. But let's use a simple technique. Now, let's look at our final answer. We need k plus 1 here, right? And here you have 4 times k plus 1 squared. And here we have 6 times k plus 1. So it means that k plus 1 is a factor of this polynomial. So I'll write here k plus 1. I've gotten the first factor. Now how do I get the rest inside here? That is where you should follow me strictly. Now, inside here, I need 4. So, let me put the 4 down. I need 4 and I need k squared. Right? I need k squared because here you see that this is k plus 1 all squared. So, at the end of the day, k will be squared. So, let me write 4k squared. Let me write 4k squared. And then expand this. Or let me expand this one so that the steps will be very, very much easier for us. Let me expand what is at the top first. For you to see. What's at the top here will be k plus 1 into 4 times k squared plus 2k plus 1 plus 6k plus 6 minus 1, all divided by 3. So you see that at the top here we are getting k plus 1 times 4k squared plus 8k plus 4 plus 6k plus 6 minus 1. All divided by 3. So you see that I have k squared here. Yes. So let's see what I was trying to do. So we saw that we should have this factor k plus 1. Now how will we get this 4k squared? Then by writing simply 4k squared. Now let us expand this. This will give us 4k cube plus 4k squared. Now you come back to here. We need 18k squared. But if you multiply k plus 1 by 4k squared, you get the 4k cube and 4k squared out of the 18k squared. So this one will remain plus 14k squared. So we have 4k cube plus 4k squared plus 14k squared. Now, how do we get this part? Let's see how we get that part. If we need that part, you see that 9 is a constant term. So if I multiply 9 by k plus 1, I'll get a certain number times k. So let's see. Let's take k plus 1 times 9. K times 9 is 9k. 1 times 9 is 9. So it implies that if I multiply 9 by k plus 1, I'll get the 9 and then 9k. So it means that this 23k, I've gotten 9k, so it will be left with 14k. Very simple as that. So I'll add here plus 9k plus 14k plus 9, and that is, I've expanded this in a very simple way. So I took k plus 1 times 4k squared. Then I took k plus 1 times 9. So you can write it as k plus 1 times 4k squared plus 9. This and that. But here I did not write k cube because k is here. If I multiply k by 4k squared, I'll get the k cube. So if I expand this one, it will not give me the whole of this, but it will give me 4k cube plus 4k squared plus 9k plus 9. Right? So 4k squared, then I'll add 14k squared to it to get my 18k squared. Then this is 23k and I have 9k. So I add 14k to this to get my 23k. You can use this idea to get here. That is very great. Now, how do we proceed? Now that you've been able to expand, let's write it here. So we have pk plus 1 equal to 4k cube plus 14k squared plus 9k plus 4k squared plus 14k plus 9, all divided by 3. Wow, that is great. So I've rearranged this so that I can do factorization. So this gives k times 4k squared plus 14k plus 9 plus 1 times 4k squared plus 14k plus 9 all divided by 3. And this gives k plus 1 times 4k squared plus 14k plus 9, all divided by 3 as our pk plus 1. Wow. Now, you've seen that we've gotten the k plus 1. That's what we have here. We've gotten 4k squared plus 14k plus 9. How do we put this to get this answer? That is what we are going to do. So join me as we go through that one step by step. Now, let's see. We have pk plus 1 to be equal to k plus 1 times 4k squared plus 14k plus 9. But you see that in the final answer we need k plus 1 squared. So here we are going to get into k plus 1, 4, then you put k plus 1 and square it. Now, you see that I've substituted k plus 1 for k. So, this substitution has effect on what I've done. So, let me expand and see. Now, this one gives 4 times k squared plus 2k plus 1. If I expand, I'll get 4k squared. This is the 4k squared here. Plus 8k plus 4. It means that after substituting k plus 1 for k and squaring it, if I expand, this is what I'm going to get. This is what I'm going to get. So it implies that I have written this here. Let me clean it for you to see. It implies that I have written here 4k squared plus 8k plus 4. But what do I need? I need 4k squared plus 14k plus 9. It means that this 9, I've not written there, it has left with 5. And this 14 too, it has left with what? 6. Wow. So that is great. So let me put it back there. We have it here. So we have 4 times k plus 1 all squared, which is equal to what we have here. Now, we need 6 times k plus 1. So let me add 6 times k plus 1. If I add 6 times k plus 1, what happens? Let's look at this. I'm having now 4k squared plus 8k plus 4. That's what I have here. And now, I'm adding 6k plus 6. Have you seen that? So now let's see. 4k squared is there. 8k plus 6k will give me 14k. But 4 plus 6 will give me 10, which is more than 9. So it implies I have to subtract 1 from this. Wow. So I'll bring here minus 1. That is why I'm bringing the minus 1. So that it will be 4k squared plus 8k plus 6k plus 4 plus 6 minus 1. and that will give us 4k squared plus 14k plus 10 minus 1. 10 minus 1 is 9, and we come back here. So that is what we have there. And then we take all divided by 3. So by the principle of mathematical induction, we've proved that if pk is 2, then pk plus 1 is also 2 for all n subset of natural numbers. So we went through this intuitive process, and it is very, very simple. Always remember to write your final answer. That one you can write it, because wherever you see n, you put k plus 1 in the final answer, and you can just look at that and then come through this process, and it will be very clear. If you have any other way of solving this question, just solve it and leave it at the comment section, or you can send it to my WhatsApp number that I've already claimed. Thank you for watching. Please kindly like, share my videos, subscribe, and leave your comments. Bye bye.